Hello everyone, in this video we are going to talk about list. List here depicts a doubly linked list. We also have some other container like forward list which depicts a singly linked list, but we are going to talk about list that is doubly linked list in this context. As we know, array and vector are continuous containers, that is, they store the data in a continuous memory. Thus, operation like insertion at the middle of a vector or array is very costly in terms of number of operation and process time, because we need to shift all the element before inserting element in the middle. So we have linked list to overcome this problem. So basically, doubly linked lists are implemented using this list container. But lists have a small problem, that is traversal. That is, for accessing an element, we need to traverse via certain elements before accessing it. Whereas in case of vectors or array, we can directly access an element in a constant time by just the index. So we need to make an instant decision between a vector or list, which one to choose based on the problem described. So we'll be looking to various functions of list that we can use, and also unlike vector we can insert the elements in the front, elements in the back, we can delete elements in the front, we can delete elements in the back also in this list. So let us look at that. So let us look at to the implementation of list. So for that we need to bring the header file as like other videos. So we will bring the header file, it is called as list, and this list is for doubly linked list. And there is one more type of header file or container we can use, that is forward list. This list is for doubly linked list, whereas this forward list is for singly linked list. But this forward list is not much used, but can be used for some problems. But this list is used more often than this forward list, because this provide the traverse in the both the direction, which have a added advantage than this forward list. We won't be talking about this forward list in this video, we are gonna tackle this list. So this provide more better traversal in the both direction by just cost of a pointer, that is back pointer, or you can say previous pointer. So let us start with this list. So the first thing we are gonna see is to declare, how to declare a list. Declaring a list. So for that, like other containers, we'll put this keyword, then this bracket and name. So in this bracket we are gonna put the data type that it is gonna hold. So we'll be holding integer value in this linked list 1. So this is the first way of declaring. So we have yet another way to declare and initialize at the same time. So for that we need to type on list, again the data type, and let us name it L2, and inside these brackets you just need to pass the values. So I will passing 1 2 3 4. So this linked list consists of 1 2 3 4 now. So let us look at how to traverse that. We'll be using our famous tool that is known as iterators. So let us declare a iterator. So for that also we need to do this kind of thing, like for list keyword and integer type, and we'll give this scope resolution operator and keyword iterator, we'll naming it it. So this declares a iterator. So there is yet another good way to declare an iterator that will automatically decide its data type. We don't need to write this long thing here, that is known as auto it. But for this auto it, need to initialize this thing here only, because while initializing only, this auto decides the data type of this it1. So you need to do L2 equal to L2 dot begin, that gives the base address of this, that is starting address of this L2. So these two are declaring the same thing, it1 and it2 are same, but it1 can be initialized later on, that is it1 equal to, let us say, L1 dot begin. So these two are iterator, these two can be used as iterator to traverse this list. But this auto provides a great keyword. This auto is a great keyword to like initialize iterator, but you need to like while using auto, you need to initialize the container there only. So basically this auto came after C++11, I think, so you need to have a modern compiler for it. So let us traverse this list. We'll be using our L2. So for that we need it1 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 not equal to, as you know, L2 dot end. So this will give the end address of our list 2, and we'll do it1 plus plus. Okay, so as you know, this is a pointer. For retrieving the value, we need to pass this star thing in front of it. So 82, sorry, it's 81. It should declare the, so it should display the elements of L2. Let us compile and check. G++ list dot out. As you can see, it is giving 1 2 3 4 as value. Let me hide this sidebar for more good view. Okay, so as you can see, if this iterator iterates the value of L2, so we are getting 1 2 3 4. Next we are gonna see two function that helps us to add the values in the front and the back. So adding values. So let us continue with L1 now. So let us comment this out. The whole thing. Yeah, so we'll going forward with L1 now. So we have it. So there are two functions known as push front and push back. Push front add the elements at the front, and push back add the elements at the end. So let us look. L1 dot push back. Let us push one. Let's copy this and push more elements. 3 4. So we have pushed 4 elements. So what happens, when we push one, it adds elements at the back. Again, if you pushed 2, it's add the element again at the back, and now the elements of linked list is 1 2, and same as this, and at this position the elements of the linked list will be 1 2 3 and 4. So it's work something like this. Yes, so for displaying, let us bring this function here. So let us uncomment it. As we have it for this L1, we'll converting this to it equal to L1 dot begin. Okay, then it not equal to L1 dot end, as we know, and it plus plus, and we'll be using it for displaying element. So let us check that this pushback function work for us or not. Let's compile. As you can see, this pushback function has pushed 1 2 3 4 at the end. So let us push one more element for verifying. Let us name it 100. Okay, let's check. As you can see, this 100 is also pushed at the back. So let us check inserting one element at the front with the help of push front function. So L1 push front will pushing, suppose, 101 at the front of the list. So our element list should start with 101. So as you can see, 101, then after this element. So even I am pushing this element 101 after this pushbacks, then also this comes at the front, because we have used push front function here. So let us push one more element at the front. Push front. Let us push -1 at the front and check. Let's clear it. As you can see, -1 comes in, then 101, then this thing. So these two are great utilities for adding values to an list. So let us look at more function that will be helpful in implementing this list. So we'll be looking at other function which is helpful in deleting the elements. So let me bring this bit up. Yep. So we have two functions known as pop front and pop back. that deletes the front element and the back element respectively, like push back push the element at the back. Similarly, pop back deletes the element from the last, that is back. So let us look at this position. We have element of the list as -1, 100, sorry, 101, 1, 2, 3, and 4. Then after that we have 100. So this is the position of our list as of now. So let us use our function. So L1 dot, let us delete the last element, pop back. So after this operation, our list will be removed by one element, that is 100. Then because we have used pop back, and pop backs remove the last element, so 100 is removed now. So let us just bring this function, this for loop out here and check. Let us compile it. As you can see, the last element, that is 100, is removed now. Let us remove one more element, L1 dot pop back. So this should remove the 4 also now. Let us check. As you can see, there is no 4 at the end of the list. So this popback function first deletes 100, this popback function and again deletes this 4. So let us use a pop front function, that is L1 dot pop front. So this pop front should delete -1 from the list, this -1 from the list. Let us compile and check again. As you can see, this -1 is also deleted. So this pop front and pop back function can be used to delete the element from the back and front. So let us look at two other utilities also. So let me bring this bit up. Yeah. So the next thing we are gonna look at is remove. So remove, just remove the element that you provide as a parameter, wherever the element is. It's in the middle, it's in the front, it's in the back, it doesn't matter. So L1 dot remove. As we have this thing in our list as of now, so we'll be deleting these two. So just pass this 2 and that's it. It will delete 2 from the list. So let us bring this for loop here and check. So it should not contain 2 now. As you can see, this 2 is removed now. So this remove function is used to remove any elements from the list. So as of now we have 101, 1 and 3 in the list. So let us look at two other utility, that is clear. L1 dot clear clears the whole list actually. So there will be no elements after this clear function. So let us compile and check. As you can see, it is printing 101, 1 and 3. So this is from this for loop. This for loop doesn't print anything. So let us comment it out and check. So as you can see, it doesn't print anything from this for loop. So this clears all the elements of a list. So let us look at let's comment it out. Look at some other function, that is L1 dot size. Size returns the size of the list that list currently have. Let us see out it. So this should return 3, as we have 3 elements as of now, as we have removed this clear function. So let us check. As you can see, it's returned 3, then prints the element from for loop. Remove this and check. As you can see, it's returned 3. So this size is returning 3. Let us clear this linked list again. So L1 dot clear removes all the elements. So this L1 dot size should return 0, as our size is 0 now. As you can see, it's returned 0. So this L1 clear clears all the element, and L1 dot size returns the size of the linked list. So let us comment it out and look to our last function that we are gonna see, that is sort. Sort simply sorts an linked list. So this sort function simply sorts a linked list from in the ascending order. So let us bring this for loop. Okay, this is the position of the for loop before the sorting, and let us bring this up, and this is the position of the for loop after this sorting function. So let us check. As you can see, it is 10113. It is not sorted. Again, after this sort function execution, we have 13 and 101 that is sorted. So this sort function sorts the elements of the linked list. So there is also other way to sort the element of the linked list in the descending order. So for that we need to pass an extra parameter out here. So we look at two various function of a list. There is also known as forward list for singly linked list. You can check it out. So for this code sample, I'll posting a link in the down in the description. You can look at to that code sample that is linked to my GitHub.